Well, researchers have been using Curie to investigate brain function for nearly 2 decades at facilities around the world. The future of Curie will be in the clinical realm. The following is a brief overview of the clinically related features of Curie. A sometimes overlooked but often appreciated feature of Curie is its ability to take single perspective MRI images and convert the flat voxels to voxel cubes that allow viewing from the 3 perspectives: axial, coronal, and sagittal. Moving the crosshair in one view affects the other 2. A maximum intensity projection provides another X-ray type view. Clinical analysis of EEG for epilepsy typically begins with the evaluation of the scalp-recorded EEG, where the emphasis is on the distribution of spike activity. Contour maps within Curie may be viewed in 2D or 3D. Epileptic spike activity can be detected automatically or manually, and the dipole solutions for each spike can be superimposed on the segmented cortex in order to visually identify whether spike activity is broadly distributed or focuses in clusters. The red dipole is the solution for the average of all the spikes, while the blue dipoles represent the location for individual spikes. Confidence ellipsoids depict the one standard deviation confidence volume for location and can be calculated for individual or average spikes, allowing the clinician to determine the validity of the result. Often, the next step in clinical evaluation is to decide where to place cortical grids and strips. In this case, on the left, a 4x8 grid was placed. Additional grids and strips may be placed as well, as shown on the right. Labels are user-defined, and the results can be saved in convenient formats or printed. The real strength of Curie, and the features that make it unique, are the ability to combine or co-register different types of data sets. For example, CT images are good for viewing bony structures and solid objects like grid and depth electrodes, but less suited for visualizing the brain. Conversely, the MRI images are suited for soft tissue, but not the bones or electrodes. Curie merges these different data sets together, as well as PET, fMRI, SPECT, DTI, and other data sets. For example, depth electrodes from the CT can be displayed with the MRI data. The different colors on the grid electrodes display positive and negative voltages. Of course, the EEG waveforms can be displayed as well. In this example, the cortical grid electrodes extracted from the CT are measured and placed on the segmented cortex from the MRI. The colors show positive and negative voltages from the EEG recordings. Display capabilities in Curie allow you to create final figures depicting selected results. In this example, a moving dipole representation of propagating spike activity is displayed in a cutaway view along with current density results. In this example, current density results are superimposed on the patient's MRI for precise localization of the activity. The source results can then be exported in DICOM and other formats for use with surgical navigation systems. Curie began its life more than 20 years ago as a highly sophisticated research tool. One branch of its development was the study of epileptic phenomena, including spikes. Curie has evolved to include clinical neuroscience research with ripples and fast ripples, frequency domain source analysis, and source coherence. The progression into the clinical realm is happening now, with multiple facilities adopting Curie as the natural evolution as the standard of care for epilepsy.